right, so we're going to now talk about the parabola, which I know we've already talked about before last semester. But now we're going to talk about the parabola in terms of it being a conic section instead of just a quadratic. And we're going to break this up into two different parts since there's a lot of information. This is kind of the hardest conic to do. Okay, so yeah, we already know what a parabola looks like, but we don't know it in terms of the definition how we've done all our other conics. And it's defined as the set of all points that are equidistant from the focus and the directrix. So that introduces a new vocab word, directrix. It is a line, and the line is going to be perpendicular to the axis of symmetry. It's going to be on the other side of the parabola. So you have the focus, which is inside the curve, and the directrix is on the other side of it. And just like it says, if you take any point that's on the parabola, when you connect it to the focus and you drop a line so that it's perpendicular to the directrix, that shows the distance from the point to a line, right? These two distances will be the same. So no matter where you are on the parabola, that will be true. So PF equals PQ. And you can imagine if P moves all the way over here and becomes the vertex to the focus and the vertex to the directrix is exactly the same distance. Okay, so using this information, it's quite simple to figure out the equation of a parabola if you're given the focus and the directrix. And that's what we're going to do for the first part here. So they've told us that the focus is 3, 5, and the directrix is y equals 1. Now this is really important. When they tell you the directrix of y equals 1, that's telling you that you have a horizontal line, because sometimes you can have a vertical line, and that means that your parabolas are going to open on the side. So we'll take a look at that later, but just keep that in mind. Sometimes your equations are going to look a little different because your parabolas are going to open left and right instead of up and down that you're used to. Okay, so the first thing we're going to do is we're going to plot our focus and our directrix. I did that backwards. Directrix and focus, okay. And then we're going to pick a point somewhere on our parabola, and we're going to give it the coordinates of x, y. We don't know what that point is. We're just going to call it point x, y. And so then we're going to drop a line down to the directrix, and we get a point, this point of intersection here. It needs coordinates as well. So if you think about the coordinates of this line, since this is vertical, it's going to have the exact same x-coordinate as that random point up there. But the y-coordinate, you're going up exactly 1 unit, which was the y equals 1. It's the directrix, right? Okay. So then if we connect this line here, these two distances, I know it doesn't look like it on the graphic here, but these two distances technically are the same, right? They have the same length. So we can use our distance formula on these 2 points and the distance formula on those 2 points and set them equal to each other. So let's do that. All right, hopefully you guys remember the distance formula. x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Okay. So now what we're going to do is we're going to do a little simplification here to try to get it into our quadratic form where we have either y equals x squared or x equals y squared. And it might be a quantity that's squared, right? So the best way to do that, notice, first of all, x minus x, that's 0. So this technically isn't even there, but we put it there anyway. You have 2 quantities here that have y, and only one has an x, because that one's not really there. So the rule of thumb is whichever variable shows up twice, those are the ones that you're going to expand. The one that is single, like this, x minus 3, you're going to leave as x minus 3 quantity squared. And, oh, by the way, we're going to square both sides and get rid of the square roots. So I did all that work, right? So once that happens, now you can eliminate the x or the y squared. They cancel out, right? So now it's just a matter of getting y on one side, everything else on the other side of the equation. Okay, so I eliminated the y squareds, combined like terms, I divide through by 8, and now I have my equation y equals 1/8 of the quantity x minus 3 squared plus 3. And if you recall, this is called the vertex form of a parabola, right? You should be able to read off the vertex by looking at this number, and that's the A that's controlling the shape. It's positive, so it's opening up. Does this all ring a bell? Hopefully it does. Okay, so moving on. The other thing that we're going to talk about in this first section of parabolas is recalling how to convert an equation into the vertex form. So we are given x squared plus 8x plus 9. So the first thing we're going to do is we're going to leave a space after the 8x because we're going to complete the square. And you could, if you wanted to, subtract the 9 and move it over to the other side if that feels more comfortable. Or you can just leave the 9 over there because eventually it's going to have to be here anyway. So when we complete the square, we're taking half of 8 and squaring it, so that's 16. We add 16. But either you add 16 to the other side to keep it balanced, or since we eventually want it over here anyway, we're going to subtract 16 at the same time. Essentially what you did is you added 0, right? 16 minus 16, 0. Either way that you want to think of it is completely fine as long as it's correct. Okay, so now let's simplify this up. We've got it in vertex form. So now we can read off the vertex is going to be -4, -7. And let's go ahead and plot that. -4, 1, 2, 3, 4, -7, 2, 3, 4, 5, 6, 7, all the way down here. Okay, so then what I wanted to review with you, if you recall the pattern, the 1, 1, 2, 4, you guys remember that? You start from your vertex and you move over 1 and up 1, and then you go back to your vertex, you move over 2 and up 4, 1, 2, 3, 4. And then you repeat on the other side, right? And then you would connect the dots to get the parabola, and I'm not going to go ahead and do that because it's just going to turn out to be a mess anyway, right? Okay, so I just wanted to quickly review that for you guys because you're going to be doing a lot of graphing, a lot of completing the square when we do these parabolas. Okay, so that's it for now. We'll take a look at the next video later, which is the more complicated stuff. All right, have